Hi everyone! Let's learn how to do mathematical operations with significant figures. In this video, we'll discuss how significant figures are used for addition and subtraction, multiplication and division, and constants. Before we get started, a key thing I want you to remember is that significant figures tell us how to round our answers. Have you ever asked your math or science teacher a question like, how many decimal places do I round to? If you know these significant figure rules, you'll be able to figure that out all on your own. Let's start with adding and subtracting. The rule here is, among the numbers you are adding or subtracting, identify the one with least decimal places. Report your answer to that number of decimal places. Here's an example, 13.68 plus 12.2, which equals 25.88. Now, how do we round our answer? 13.68 has 2 decimal places and 12.2 has 1. 12.2 has fewer decimal places, so I also want my answer to have just 1 decimal place. I'll round my answer to 25.9. At this point, a lot of students will say, no, that's obviously wrong because the calculator gives me 25.88. But remember, we're using significant figures to help us round our answers. Why do we do this? What is the logic behind this rule? Think about the scenario. Imagine that when you go to school, the distance from home to school is 2 miles, plus or minus 0.1 mile. Now, what if you decide that you don't want to start measuring the distance from right outside your front door? You want to start inside the door, which adds about 3 feet of distance, or 0.0006 miles. Are you now going to say that the distance from home to school is 2.0006 miles, plus or minus 0.1 mile? No. That doesn't make sense because the original plus or minus 0.1 mile means the distance could be 1.9 miles or 2.1 miles. There's already a big uncertainty there. Even if you add 0.0006 miles, that number is smaller than the original uncertainty, so it doesn't matter. This is why when we add or subtract, we round our answer to fewer decimal places. Whether we start outside the door or inside the door, we would still say that the distance to school is 2 miles. Let's do some more practice. In this first example, what do we round our answer to? Well, 2 has 0 decimal places and 1.862 has 3. We go with the least decimal places, so we round our answer to the ones place. The answer rounds to 0. It does look weird, but again, we're rounding. Here's another example. 30 minus 14 is 16. What do we round to? 30 goes to the tens place and 14 goes to the ones place. 30 has the bigger place value and is less precise, so we round our answer to the tens place. We round our answer to 20. Now let's get into multiplying and dividing. The rule is, among the numbers you are multiplying or dividing, identify the one with the least total significant figures. Report your answer to that number of significant figures. Here's an example. If we multiply 132 and 11, our answer is 1,452. 132 has 3 sig figs and 11 has 2. Go with the least sig figs, so we'll round our answer to 2 sig figs, which is 1,500. Why do we do this? Imagine that you have a circle and its radius is 2 meters. Then you use the radius to find the circumference. The circumference of a circle is 2 pi r. Let's be fancy here and use a lot of decimal places for pi. Here's our circumference. Does that mean after multiplying by pi, we suddenly increased the precision of our measurement from 1 significant figure to 7 significant figures? No. Our original measurement has only 1 significant figure, so we're going to round our answer to just 1 significant figure and round this to 10 meters. That brings us to constants like pi. Do not consider constants when you're doing significant figures. Constants are values that never change, so we say that they are infinitely precise. They have infinite significant figures. For example, we're used to saying that 1 foot has 12 inches, and we mean exactly 12 inches. So we can think of this as 12.000 with infinite zeros. Same thing with pi. You might think of pi as 3.14, but pi has many more decimal values after that. Plus, pi doesn't come from a lab measurement, and significant figures are only used for numbers that come from lab measurements. Let's do some more practice with multiplication and division. Here's the first example. 2 has 1 significant figure and 12 has 2 significant figures. So I'll round my answer to 1 significant figure. My answer rounds to 20. Here's our second example. 30.00 has 4 significant figures and 300 with a decimal has 3 significant figures. My answer is 0.1, but I want my answer to have 3 significant figures, so I'll write this as 0.100. Or I can put this in scientific notation as 1.00 times 10 to the negative first power. Remember that for scientific notation, only the coefficient counts for significant figures. Thank you for watching this video, and I'll see you next time for combining different math operations.